Geology is often the black sheep of the hard sciences. Other fields such as chemistry, physics, and biology are often the ones given exposure to the popular media. Today, I'm going to give you a brief journey over the history of geology. Greetings, my name is a magmatic sage, and this is Geology Made Easy. So you might be wondering, how did geology came to be? When did it start, or how did it develop over time? Well, it all started in Antiquity with the Greeks. Ancient Greeks developed basic geological observations and concepts regarding the world around them. One famous philosopher, Aristotle, student of Plato, founder of the Lyceum, and writer of the Nicomachean Ethics, observed the decomposition of the land and led to a theory that the earth changes slowly over time, and these changes cannot be simply observed in one lifetime. You could say that this is one of the evidences of people conceptualizing about deep time. We will talk about it later on. Aristotle's student, Theophrastus, was the one who made the greatest contribution to the science at that time. He made a book on stones, on which he described minerals and ores from mines both local, such as within Larium near Athens, and foreign. He also attempted to formulate classification schemes for minerals, such as describing it based on their hardness and their color. Fast forward to the Roman period, Pliny the Elder created one of the first encyclopedias, Naturalis Historia, or Natural History. Included in this book is the in-depth study of minerals and metals, which expounded on the works of Theophrastus. He was one of the first to describe the origin of amber as a fossilized resin derived from trees, as he observed the insects trapped within them. And finally, he laid the fundamentals of crystallography by recognizing diamonds' octahedral habit. Antiquity was truly an age of intellectual progression. Despite the technological absence to observe the earth, people of the antiquity formulated the groundwork for the science of geology. Now we move on to the next age on our list, the Middle Ages. Away from the European theater, we move on to the land of Asia, where three particular people contributed yet again to the fundamentals of the science. Abu Hayyan Muhammad ibn Ahmad al-Burini was a Khwarezmian Iranian scholar and a polymath during the Islamic Golden Age. He was versed in physics, mathematics, astronomy, history, and natural sciences. He is also one of the earlier Muslim geologists. He wrote things about the geology of India, theorizing that the Indian subcontinent was once a sea. He also used the concept of hydrostatic equilibrium to determine the density and purity of minerals and precious stones. He classified gems based on their specific gravity and hardness, rather than just color, which was common practice at that time. Ibn Sina was a Persian polymath and was one of the most significant physicians, astronomers, philosophers, and writers of the Islamic Golden Age and father of early modern medicine. His greatest contribution to geology was a section in his encyclopedic work called Kitab al-Shifa, or the Book of Cure, Healing, or Remedy from Ignorance. In Part 2, Section 5, he made a commentary on Aristotle's mineralogy and meteorology. Topics he discussed about include the formation of mountains, the advantages of mountains in the formation of clouds, sources of water, origin of earthquake, formation of minerals, and diversity of the Earth's terrain. Then lastly, in the lands of medieval China, we have Shen Kuo. He is a Chinese polymath and statesman of the Song dynasty. He was, I'll show you the list. You could say that he was not only a genius, but super one at that. In the field of geology, he laid the groundwork for the subfield of geomorphology. He observed processes such as sedimentary uplift, soil erosion, deposition of silt, and the presence of marine fossils found in the Taiyang Mountains, fossils that are hundreds of miles away from the ocean. From this observation of fossil shells in the mountains far away from the ocean, he inferred that the land was formed by erosion of the mountains and by the deposition of silt. He also formulated the theory of gradual climate change by just observing preserved ancient petrified bamboos found underground near Yangzhou in the dry northern climate of Shanxi province. The Middle Ages was a time where Islamic Golden Age and the Chinese philosophers laid the groundwork for the science of geology. Fast forward to the 17th century. In this era, geology became its own entity or field within the world of the natural sciences. It was discovered by the Christian world to give interpretations for the deluge or the Great Flood myth, and how it formed the world's geology and geography. Or in other words, the formation of geology was a way to give scientific evidence to prove that a great flood really happened. In 1696, a book by William Whiston titled A New Theory of the Earth was the widely accepted theory for the origin of the Earth. It was also the earliest accounts of the movement known as catastrophism. Whiston used Christian reasoning to prove that the Great Flood really happened, but the highlight of the 17th century was none other than the famous blessed Nicholas Steno. Niels Steensen, Latinized as Nicholas Steno, was a Danish scientist, a Catholic bishop, and a pioneer of both anatomy and geology. His greatest contribution to geology was the formation of stratigraphy and his famous stratigraphic laws, namely the principle of superposition, the principle of original horizontality, the principle of lateral continuity, and the principle of cross-cutting relationships. These will be discussed later on. And he also gave one of the most important foundations of crystallography, the law of constancy of interfacial angles. We will also talk about this later on in a future video, but this alone proved how important Nicholas Steno was in the realm of the geosciences. The 17th century was dominated by Christian beliefs due to the roots of medieval ages. Nonetheless, this was the slow transition to a more scientific age, the Age of Enlightenment. The 18th century. In this age, many became interested in minerals and other components of the Earth's crust. And since the booming of mining due to its economic importance, knowledge about ores became relevant, and the need for accurate geological information was essential. This was also the time where two schools of thought were battling for the origins of the Earth. These were the Neptunists versus the Plutonists. Neptunism is the idea that the Earth's surfaces or the geological strata was created due to a biblical deluge-like event. It theorized that rocks came from the early Earth's ocean. On the other hand, Plutonism is the idea that the Earth originated from intrusive magmatic activity, or volcanism. These rocks are then weathered, eroded, and deposited into the seabed, reformed into layers of rock, and raised again. The proprietor for the Neptunist movement was none other than Abraham Gottlob Werner. He was a German geologist who has an interest in the systematic identification and classification of minerals. He published his book on descriptive mineralogy called Von den Auslichen Kennzeichen der Fossilien, on the external characters of fossils or of minerals. In 1777, Werner had a theory about the stratigraphic successions of the Earth that could be divided into 5 formations listed on this image. As time went on, people questioned Neptunism and biblical point of view of the creation of the Earth. One of these people was Georges de Buffon, a French naturalist, mathematician, cosmologist, and encyclopedist. he published a book called Histoire Naturelle, in which he questioned the deluge myth and other popular biblical accounts by Western and other Christian theorists of the history of the Earth. Based on his experiments on heating and cooling of metallic globes, he theorized that the age of the Earth was around 75,000 years. Another person who not only questioned Neptunism but also led the Plutonism movement was none other than James Hutton. James Hutton was a Scottish geologist, agriculturalist, chemical manufacturer, naturalist, and a physician. Hutton called the father of modern geology, as he was the one who played an important role in establishing geology as a modern science. Later on, he influenced the creation of uniformitarianism thought, in which the same natural laws and processes that operate in our present-day scientific observations have always operated in the universe in the past and apply everywhere in the universe. Or in layman's terms, the present is key to the past. Another important contribution of Hutton was the concept of geologic time, or in John McPhee's term, deep time. It's a concept which shows the complex development and changes of the Earth and how all of this spanned throughout a very long time, unlike how the Neptunists would see the world. Of course, in the modern age, we already dated the approximation of 4.6 billion years more or less as the age of the Earth, but during that time of Hutton, no one expected it to be that old. The 18th century gave us a massive leap and more geologic theories and knowledge on how the Earth came to be. And now we enter the 19th century. In this time period, the Industrial Revolution and the need for mining resources caused the development of the stratigraphic column as more and more areas were excavated. First on our list of sciences is Charles Lyell. Sir Charles Lyell, 1st Baronet, FRS, was a Scottish geologist who demonstrated the power of known natural causes in explaining the Earth's history. An astute student of James Hutton, he authored the book Principles of Geology. In this book, he championed the uniformitarianism thought in which the Earth was shaped by the natural processes that are still happening today, as mentioned earlier. William Smith, an English geologist and a mining surveyor, found out that fossils were best to distinguish formations of landscapes around the country as he worked in building canal systems. He used this knowledge to produce the first geological map of Britain. Contemporaneously, Georges Cuvier was a French naturalist and zoologist, sometimes referred to as the founding father of paleontology, realized that the age of the fossils could be determined using the stratigraphic column. This idea later on became the principle of fossil succession. It states that groups of fossils appear in a chronological order through their vertical placement in sedimentary rocks. With the use of stratigraphic column coming to fruition, several geologists further studied and refined this idea. One funny event occurred during this time period. It was the rivalry between Adam Sedgwick and Roderick Murchison, which was later called the Murchison-Sedgwick controversy. Adam Sedgwick was a British geologist and an Anglican priest, one of the founders of modern geology. He was the one who established the Cambrian period and investigated the Devonian as well. On the other hand, Roderick Murchison was a British geologist who served as the Director General of the British Geological Survey from 1855 until his death in 1871. The controversy was that while Murchison was investigating a part of Wales, he assigned some upper parts of Sedgwick's Cambrian period unto his own lower parts of the Silurian period. It was Charles Lapworth, FRS, FGS, an English geologist who made the Ordovician system as a compromise for the disputed strata, ending the Murchison-Sedgwick controversy. Another famous person who got influence in the geological realm was none other than Charles Darwin. Charles Robert Darwin was an English naturalist, geologist, and biologist. Aboard the famous HMS Beagle, he met with Captain Robert Fitzroy, an English officer of the Royal Navy and a scientist. Fitzroy gave Darwin a copy of the book Principles of Geology by Charles Lyell. As he read the book, he later on became an advocate for the idea of uniformitarianism and even made criticisms for it. His study of giant fossils led him to theorize about their extinction and led to the famous theory of evolution by natural selection, published in the book On the Origin of Species in 1859. And lastly, in the latter part of the century, William Thomson calculated the age of the Earth between 20 million and 400 billion years. He used his theories of thermodynamics to theorize that the Earth was once completely molten object and cooled over a long period of time. The 19th century was yet again another leap forward for the realm of geology. We saw the use and development of stratigraphy, paleontology, and even historical geology. The 20th century was an age of innovation for geology with the introduction of radiometric dating. Arthur Holmes was a British geologist who made major contributions to the understanding of geology. He published the famous book called The Age of the Earth, in which he argued for the use of radiometric dating rather than geological sedimentation for estimating the age of the Earth. He later on presented the age of the Earth to be 4.5 billion plus and minus 100 million years using the uranium isotopes as basis. With all of his contributions, he was dubbed the father of modern geochronology. Another contemporaneous was Alfred Wegener, who was a German climatologist, geologist, geophysicist, meteorologist, and a polar researcher. In 1912, he proposed the famous continental drift theory. This theory proposes that continents were once joined together as part of a single landmass or supercontinent called Pangaea. This supercontinent broke apart later on, and this is evident by how modern continents fit together like jigsaw puzzles based on the outline of their coastlines and their shape. Unfortunately, this idea was not accepted at the time due to the lack of mechanism or cause for this drift. It was not after the Second World War when supporting evidences started to appear. With the emergence of naval radar technology, the study of ocean floor began. So in the 1950s and 60s, an American geologist named by Bruce C. Heezen, alongside with his colleague Marie Tharp, an oceanographic cartographer, mapped the mid-Atlantic ridge. This provided the way for Robert S. Dietz, a marine geologist, geophysicist, and oceanographer, and former U.S. Captain Harry Hammond Hess, who is also a geologist, expanded the study of the ocean floor and postulated the concept of sea floor spreading along the mid-oceanic ridges. Keith Runcorn, a British physicist, added the concept of paleomagnetism, that the continents move relative to the Earth's magnetic poles. Another geophysicist by the name of Tuzo Wilson added the concept of transform faults, where two land masses move relative to each other horizontally, which played a major factor in the movement of these continents. And finally, Edward Bullard and colleagues showed a computer calculation in which how the continents along the Atlantic Ocean would have fitted together, which became known as the Bullard's fit. With all of these evidences, from the concept of Wegener's continental drift to the seafloor spreading of Dietz and Hess, the concept of plate tectonics was born. We will talk about plate tectonics later on in another video. 20th century gave the tools to deepen our understanding of the Earth and its processes. Concepts like radiometric dating and plate tectonics, we get to see how amazing and complex our wonderful world is. And now, the current century, the 21st century. With computers ever getting more powerful, technologies getting more advanced, geology has never been more alive than ever. Technologies like satellite imagery, remote sensing, graphic information systems, drones, and much more made geology accessible to the common man by a press of a button. Geologists have even started to look at the sky. Using geologic principles, scientists have started to look at the geology of the Moon, Mars, and many other planets. Geology had humble beginnings. We learned that each time period in history, there was an evolution on how the science came to be. Next video, we will talk about rocks and minerals. If you liked the video, please leave a thumbs up and a comment down below. And don't forget to subscribe to the channel. Thank you.